We're looking at more integration, and we're going to look at some variations of the integral of a linear function nested within some other function, and we can call that integral of f of ax plus b with regards to x. Now we've already looked at a few of these, so just let's quickly remember this and identify that we have. We've looked at in a previous video this one here. So the integral of 1 over ax plus b dx, and we know that that equals 1 on a times the natural log of absolute ax plus b plus constant. Now that is one of these because we have that. So the ax plus b is clearly identifiable there, and the function is, if we make a u substitution, the function is something to the -1. So yes, there we go, there's an example. Another example, if we look at, say, trigonometry, would be something like the integral of cos of ax plus b, where a and b are real numbers, of course. I'll identify that up here. I think you knew that, but constants, in other words. So we've seen that one before, and that one would be -1 on a sine ax plus b plus constant. Sorry, I shouldn't have had the negative there. So we've seen these before. Another one, if we look at base E exponentials, we've got e to the ax plus b with regards to x. So they've all been looked at. What about something new? Well, let's have a look at this. Here we have essentially a linear function inside a power term. So what's the story with that? Well, it does have a result. So if we take the integral of ax plus b raised to the r with regards to x, we actually get this result here. Plus constant, where r is a rational number, but not -1. There's a set difference there. Alright, so r is a rational number, integer over integer, but it cannot be equal to -1. Why is it so? Well, let's grab part of that result, this part here, and let's call it f of x. So let's consider f of x equals ax plus b to the r plus 1, and let's try and use the chain rule to find f dash of x for that, the derivative. Okay, well, we have to take the derivative of the inner function, which is ax plus b with regard to x, and that's a, and then we take the old power and multiply it on the front as a coefficient with the a, and then we take the inner function raised to the 1 power less. This is all chain rule, so you could make a u substitution and do it the long way if you like. You know, so if you need to do that, go and pause the video and do that, but you'll see that the results are following, such that we have this. So if we go back to the premise here, the integral of ax plus b to the r dx, we grab this here and we take the antiderivative of, considering this, the antiderivative of this entire line here, of course, should be that there, but we're only taking part of it. So what we need to do, and considering these are just coming together as a constant or a real number, we will get back to this here with the reciprocal of this, because we have to divide by that just to get this bit here by itself. And there's that same result. So we get, again, we get 1 over a by r plus 1 by ax plus b to the r plus 1 plus constant. And r does not equal -1. Whether you remember that or are able to generate that, that's up to you. But it is a variation we will be using, and let's have a look at one example now before we finish. Okay, so let's look at the integral of 2x minus 1 all raised to the power -2. Let's identify, for the sake of this video, the values there, which should link up to the overall result above in blue. And we would have here, it's like saying r is equal to -2, a is equal to 2, and b is equal to -1. And we can just follow the rule. We would have 1 over 2 outside of -1 multiplied by 2x take 1 to the -1 plus c. Simplified, that would be 1 over -2 outside of 2x take 1 plus constant. So really, when we look back over the video, the only new thing introduced here was our rule, which is best written there. The thing to be aware of course, is that we have seen manifestations of this before. Exponentials, we've seen trigonometric manifestations, we've seen manifestations which are based on a reciprocal type deal, all emanating from 1 on x and developing on from there, and they give log results. But the new one is worth noting, the one that involves a linear function within a power term, and the thing to know is they all follow that general rule or that general format.